Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it later on demand. We'll be sending out an email later on this afternoon that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can before the end of today's webinar. Okay, with that, we'll go ahead and kick off today's webinar, which is optimizing time series performance in the real world. Our speaker today is Sam Dillard, who is sales engineer at InfluxData. Welcome, Sam. Thanks for joining me today.
Thank you, Charlene.
All right, great. Well, I know you have a lot to go over, so I'm going to put myself on mute, let you get to it.
Right on. Okay, well, welcome everyone. Thanks for joining us. Or for listening later, if that's who you are. Again, I'm Sam Dillard. I'm a sales engineer. I've been in this capacity at Influx for over 3 years now. So I have a lot of experience working with our end users and our paying customers with optimizing. I mean, there's other parts to the role, but a lot of what I do is help optimize the performance from a writes and reads perspective of InfluxDB, whether it's open source usage or enterprise clustering, any kind of architecture, any kind of configuration of Influx, whatever the use case. I have a lot of experience with that. So, if you have questions at the end of this, please don't hesitate to write them into the chat. Let's get started. So the agenda for this, it's actually, there's a lot of meat inside of these categories here, but basically it's the following. So we're going to talk about optimizing, obviously. I will touch briefly on hardware and resource consumption. There's not a lot to be said there, but I will have a slide on that. The meat of this, however, is about the way you write data to Influx and the schema that those writes imply. So if you're familiar with Influx, you probably understand that Influx is a schemaless database, which also means that it defines its schema at write time. So the write method becomes not only really important for performance, but also really important for the schema that you're defining within the database when you write. And that has major implications for when you're querying and just simply exploring the data itself. So we'll talk about write method, and then we'll talk about schema and kind of line protocol, which is the language that Influx speaks. And then we'll do some Q&A. So not a lot to be said here. This is just one slide. I get this question a lot, though. Is there any OS tuning required? There is not. So Influx is very OS agnostic. There's no tuning required, at least that we know of, or that we haven't, found anything through testing to tune there. The assumption of time series data, however, is that it's very high velocity, ingest and read out. So one thing you don't want to do is have your disk be a bottleneck. So IOPS is really important. We usually suggest SSDs, or if you're using AWS, maybe an NVMe. I know those are expensive, but if you have a high workload, sometimes it's necessary. And then this is a kind of a Goldilocks principle here. 70% is really honestly kind of an arbitrary number, but the reason why we call out this number is that we obviously want you to use a lot of your box, but you need some headroom for, periods of high ingest of metrics, if that's appropriate to your use case, or maybe high peaks of reads, of queries. So maybe you have a lot of engineers that are looking at Grafana or Chronograph dashboards, and they all log in at the same time, and there's a big spike in query load. The other thing that can peak is compactions. Compactions are happening in the background, depending on shard durations and things like that. Compactions use CPU and memory, and so there's implications there that you need to have room for. And then, not often done, but it does happen, backfilling data. When you write data to old shards, there is recompactions that happen. So again, you need some headroom for that. So that's all we have for that piece. So now we get to the meat of it. So this is about the right method, this section. And what I mean by right method is honestly the way that you kind of structure your data, your time series data pipeline, and the kind of the way you format your data. And I think the most important takeaway here is the use of Telegraf. So this is our Telegraf tiger here. It's good to get familiar with him. Telegraf is Influx's open source collection agent that is written in Go. There are probably 50 million instances of this in the world right now, daily active users or daily active instances of this. So it's very popular. It's important to understand that it is plugin driven. So its plugins are defined in a TOML configuration file, and there's an example here to the right where I've turned on. It's as simple as this. I've turned on plugins for measuring CPU, memory swap, disk, and so on the local host. Then there are other plugins that can actually be configured more specifically, and in this case, HTTP. This is a scraping plugin. So Telegraf will act as an HTTP endpoint scraper. So in this case, I've fed it 2 local applications where I'm assuming that there's some kind of JSON data exposed at those endpoints, and Telegraf's going to scrape them and parse them accordingly. There's a whole lot you can do with kind of specifying how you parse that JSON as well, but that's probably not for today. Besides ease of use, Telegraf is, it's written by InfluxData. So the people who wrote and maintain InfluxDB and Telegraf are the same people. So it is optimized for interfacing with InfluxDB. It's good at formatting line protocol, which we'll talk about later. Handling retries, which is, something that a good client library might do. Modifying batch sizes and jitter intervals. So basically changing the frequency to which you actually flush data to Influx or any output, and how you balance those flushes. And then tag sorting. So InfluxDB will actually sort tags lexigraphically. That's for purposes regarding querying. You can have Influx do that for you, but if you are worried about performance, you're having some kind of bottleneck, then it's good to have that decoupled from the data store itself, and so you can do that in Telegraf. Pre-processing is something that Telegraf also does, and this is not necessarily used by a lot of people. It may be just an education thing, but Telegraf is good at pre-processing at the edge. So converting tags to fields, fields to tags. If you're not familiar with those terms, you will be later. Regex transformations, glob transformations, renaming pretty much any object in Influx. Obviously, it doesn't rename data that's already in the database, but for future writes, it will. Aggregations can be done. So this is when if for instance you don't want to write raw data to Influx because you don't need it, or you're having performance bottlenecks and you can't upscale, then you can do aggregations at the edge, and you can do it in a various number of ways. So yeah, aggregating data means you lose some information, but if you aggregate in multiple different ways, you can often glean a lot of insights even from your aggregated data. So Telegraf can be used for that. This is just kind of like a visualization of my thought process on what's going on in Telegraf. This is technically accurate, maybe hopefully it makes sense, but this is what's going on in Telegraf. You configure your input plugins, which are over on the left there. So like the TOML file example I showed earlier, those are the ones listed there are some popular ones that people use Telegraf for. When inputs go out and collect their data, they send them to any processor plugins that you've configured. You may not have any configured, that's fine, it'll skip that step, but if you do, it'll do those processes. It'll transform data, decorate data, filter data however you like, and then it will go to the aggregations if you have any of those configured. And then from there, it'll write to any number of outputs. I believe today we have 25 to 30 different outputs, so Telegraf is not InfluxDB specific. We obviously love when it is, when people write to InfluxDB, but you can write to message queues to other monitoring services like CloudWatch. You can write it to Datadog even. You can write it to a local file. So let me go back here. So there's one kind of plugin I didn't talk about here. So we've got inputs, processors, aggregators, and outputs. There's a parser plugin, but these are actually configured within an input. There's a whole multitude of data formats that we support for processing, or for parsing, excuse me. In this case, well, our most popular are JSON, CSV, and Graphite. I've seen others in the field. There's actually a longer list than what I've showed here. In this example configuration at the bottom here, I have an HTTP listener plugin configured. So the other HTTP one I showed you was a scraping plugin. So that was a pull method. This is an example of Telegraf sitting, somewhere remotely or even locally, and in this case it's local actually, and listening for HTTP requests. And in this case it'll be on port 8080. It's expecting data format in CSV, and then the CSV parser plugin has these parameters that you can choose to decide how you parse that CSV object essentially. So in this case, I'm feeding a CSV file that does have a header row, so I don't need to call out the column names, and so I tell it there's one header row, and then it'll essentially parse how I choose it. So I can tell it what the time column should be, what the measurement name should be by column, and then what the tag should be, and then everything else is going to be fields. And again, if you don't understand what I'm talking about with regard to measurement tags and fields, you will. This is just an example of how you can turn CSV into optimal line protocol, and that's what I've done here. If there is no header, you can obviously in that commented out line in the middle at line 33, you can call out specifically what the columns are from left to right. So just an example of one of the many parsing jobs Telegraf can do. So going back a little bit to the innards of Telegraf and the fact that you can output to multiple different outputs. In this case, this is an example of Telegraf at the edge outputting data to a message queue, and all of the ones listed here are supported. I think there's even some more, but this is probably in order of the most popular that I see at least. So this is an architecture of someone who wants to write to a message queue, kind of batch up their writes, and then consume off the end with another Telegraf, and then write to InfluxDB. And this has a lot of benefits here. This is one, batching writes is good, right? You don't want to have 10,000 Telegrafs writing directly to an InfluxDB instance because it's too many open connections. There's a lot of HTTP overhead there. So batching up the writes into a message queue is great for aggregation, or just merging of the metrics, but also for persistence in your data pipeline. And then Telegraf can intelligently pull off of that queue, and when I say intelligently, I mean if it can't write out data, it'll stop pulling off the message queue. So it'll remember the offset and then write to InfluxDB. Here's another architecture example. This one is not persistent. Telegraf does not persist data, but it is one that some of our larger customers do use to aggregate data. In either case, the edge Telegrafs or the interstitial Telegrafs here in the middle can do processing, parsing, aggregations, however you see fit. It's very flexible. So balanced ingestion helps. This goes back to batch sizes and jitters. So this is just a visual example of some customers that we have. This is obviously anonymous, but this is some of our cloud users. I got these screenshots from our support team. The top guys, they're making use of this 15-minute interval of their, open possible HTTP connections. So they're spreading it out quite a lot. The guys on the bottom are not spreading it out so much, right? So they're kind of essentially wasting resource time and allocation. And here's just another example of that happening with CPU. So the CPU usage on the top is well spread out. CPU usage on the bottom is not so spread out. So you're just not, this is basically common sense, but this is something you might want to look out for. So you can change batch sizes and jitter intervals to kind of find the sweet spot here. Okay, so why does the right method matter? Well, because schema is defined by it. So I already mentioned that. it is really important to understand that, a schemaless database, it may be schemaless, but it is also opinionated. So there are schemas that are better than others. So this is why we'll talk about that. Improving schema is basically threefold. Reducing cardinality if applicable to your use case. That's always good. I know cardinality is a major time series problem that Influx has mostly solved, but it does require a little bit of education on how to do that. Encoding data or information into keys or series keys. And we'll talk about what that means and what that looks like in a second here. But that's something we want to reduce. And then key lengths. Sometimes you can't do that, but if you can, it's best to try to do that, because at scale, obviously key lengths, especially series key lengths, take up memory. And so the more you have and the longer they are, the more RAM you need to allocate to your boxes. And by doing all these things, we increase performance overall. And then an often overlooked advantage of doing this stuff is increasing the explorability and readability of your whole data set. Some people, maybe if you're the maintainer of your instance, you have a very good idea of what data is in there, but your end users might not, right? So it's good to give them an opportunity to be able to explore their data. Sometimes people don't know what they're looking for until they find it. I see that happen all the time. So this is just a quote from one of our customers. This is regarding line protocol. It's a different type of format than a lot of people are used to. It is a feature. It's not a bug. The fact is, to take advantage of this feature, it does require some thinking, right? And that's what Telegraf does for you. Telegraf really does the thinking for you. But if you're not using Telegraf, or if you are using one of the parsers, for instance, in Telegraf, it's good to have this foundational knowledge to go forward. Especially if you're writing your own data, custom metrics from your applications with a client library, or even not a client library, just doing something really basic. So this is a quick primer on what line protocol is. So at the top there, or I guess the second line, the one below the title there, is an anonymized version of line protocol. If you're not familiar, so measurement, that is everything that is before the first comma or the first space if there's no comma. And what a measurement is a grouping or kind of a categorization of logically alike metrics. You can think of it as a SQL table. It's not a SQL table, so don't equivocate them. But you can think of it that way. The way you treat them is similar. Then you have your tag set. So a tag set is just your metadata. It's the things that describe the assets that you want to distinguish by in queries and when you're exploring your data. There shouldn't be any real data in here, but actually just metadata. So, IDs and names of users and URLs and things like that. And then fields, your field set, are the things that you're actually measuring. The values that are changing over time, right? The actual time series data. Both sets, tag sets and field sets, are comma separated key value pairs. So you can have any number of tags, any number of fields in a single line of line protocol, all associated with the same measurement. And of course, you have your timestamp. Notice the punctuation here. It's important. So that first comma separates the measurement in the tag set. The first space separates the tag set and the field set, and then the second space, the field set and the timestamp. A couple things. So people often ask me what to make what. So obviously a measurement is, again, just kind of a category, right? So if you're measuring CPU of a host, there are multiple ways to measure CPU, right? You don't want to just get CPU total or usage user or usage system or usage idle, right? There's different ways to do it. So group them all into one measurement called CPU, and then when you write your CPU metrics, you can write all of those different metrics into the same line. And then your tags would be things like region, host, well, in that case, or maybe container ID, something like that. PayPal is one of our customers, so they might have something like transactions. I don't know if they do, but they might have a measurement called that. And then the fields they would be tracking there would be US dollars, response time, the duration of the transactions in milliseconds, whether it timed out or not, and so on. Tags, again, they're your metadata, but Another way to think about it is things you want to group by. So you can only group by, with our query language, you can only group by tags, not fields. But on the flip side, tags cannot be operated on with math. So fields can only be done that way. And this is by design, right? We want fields to be your metrics, right? The things that you're going to add and subtract and do operations on, do means and other kinds of aggregations with. So that's what we call fields. Fields, we write those values to disk. So this is where cardinality comes into play. Tags are all in memory indexed. Fields their keys are memory mapped, but the values are stored to disk. So when you're not going to group by something, it's often better to keep it as a field to reduce your total cardinality, your total RAM usage, and then your cardinality also affects performance somewhat as well. So hopefully that makes sense. We're going to kind of beat this into you guys for sure over the next few slides. So don't worry if it's still a little confusing. And again, we'll have a Q&A later. So these are the goals of line protocol. We'll not talk about number 4 today because that, maybe we'll assume you're using Telegraf, and Telegraf does that for you. But going back to not encoding data into your measurements or tags, I said series key, but that's what basically measurements and tags are, your series key. Maybe you don't know what it means to encode data into keys. Well, if you see field names like value or counter or gauge, which are all very common in the field today, you know that there's probably some kind of descriptor contained in the series key itself, right? Because if you have no information in the field key, it has to be contained somewhere else so you understand the context of the value you're writing. Another thing you want to do is try to write as many fields per line of line protocol as you can. Number 1 will allow you to do this, right? If you have field names like value or counter or gauge, you literally can't do this if you want to make sense of your data. You can't write 2 different fields named value. Well, one, in Influx, they will overwrite. But let's say that wasn't a thing, it wouldn't even make sense in the first place. You wouldn't know what those values were. You wouldn't know how to distinguish them. Writing multiple fields in the same line also improves performance. It decreases payload by a lot sometimes. I'll have an example of that at the end. But it also improves write performance at the disk level. And then separating into primitives. So this is basically best for it doesn't really have much to do with write performance, but definitely with read performance. So, reducing the amount of regex you'd have to do group bys and from clauses and things like that. And there will be examples of that coming up as well, if that doesn't make sense. So here's an example of what I'm talking about with regard to encoding data into measurement names specifically. So this is basically Graphite metrics, if you guys are familiar with that. I don't remember if there's actually a value key there, but it's an implied one if not. But it's this dot notated thing, right? So and that works great for Graphite or Whisper. But if you write this line to Influx directly without parsing it first, into optimal line protocol, you'll notice that there's no comma here at all. So if you remember the rules of how Influx parses lines of line protocol, this whole piece here from CPU all the way to usage user is going to be your measurement name. And because there's so much data encoded in there, you're going to have not only a ton of measurements, but also when you want to do any kind of, you have no tags to group by, you have no metadata there, right? You also have a value key that has no information in the key name itself, so you can only put one value per line. There are also, having a lot of measurements can have some really negative repercussions. One, writing new measurements is actually the most expensive write operation in Influx, so you want to try to reduce that. Measurement cardinality also reduces, the higher your cardinality of measurements, reduces explorability. If you're a user of Influx, you've probably used a show measurements command. If you have 20,000 measurements, that query might hang. It might even crash your instance if you don't have enough headroom. And you want to be able to show your measurements. You want to be able to explore your data. And then in InfluxQL, as you might know, you can't do math between measurements. So if you want to compare two different fields from two different measurements in some way, you can't do that across measurements. So having lots of disparate measurements is going to reduce your ability to do operations on your fields or on your values. So at the bottom here is an example of a proper way to parse this out. So you've got your CPU measurement because it's to the left of a comma. You've got two tags that were implied by the Graphite metric. You've got host and region. And this is also an example of separating primitives, and the next slide will talk about that in more depth. And then we have a field key, excuse me, a field key that actually has information in it. So you could see that if the series key to the left side of that first space, were the same and we had a different metric to record, we could pivot it and put it into that same line. In this case, that's not the case. So if these three lines here are they all have different series keys. Or I guess no, yeah, they all have different series keys. So we couldn't do that, but I will show you examples of doing that coming up. Not overloading tags or separating into primitives, however you want to call it. In this case, the bad lines here, we have a proper measurement name, but the tags could use some work, right? We have a single tag, server equals localhost.uswest.usage user. So one, obviously we don't have information in the field key, but we've also got two tags in one. So now if I want to group by either server or host or both, I have to use regex. So instead, what we want to do is separate that out. So these good lines here are showing you that these tags can be separated out into primitives. And again, we've pivoted the field information into the field key itself. So going back to Graphite, it's a very common migration pattern. We get a lot of Graphite users moving to InfluxDB, so I thought it would be topical, at least or relevant to pull this out. So if you take a Graphite metric like the one above, cpu.usage.eu west.idle.percentage equals 100, you can run this through any of the supported input plugins. In this case, it's again the HTTP listener. I've prescribed that I'm going to be seeing Graphite metrics. I tell it what kind of separators I want for cases where I have you'll see this measurement.measurement there in this templating. So there's a whole documentation page on templating, but this is just an example of me using a template to tell Telegraf how to parse this Graphite line into what you see below. So the CPU underscore usage took those two dot notated words, used the separator of the underscore, made that measurement name, and then created a tag of region and then a field of idle percentage. And that field was determined by a glob pattern there in the templating. So it's actually relatively trivial and straightforward to do this kind of parsing in Telegraf. And once you've configured it, you're done. So I'm actually excited to say that this is a new processor plugin that is in Telegraf, and it enables the kind of thing I'm talking about. So the first thing here is reducing or taking the field information out of the series key and putting it into the field key. So that's you'll see this example at the bottom here is doing that. It's modifying those upper two lines into the bottom two. So that's step number one. Step number two, and this one is going to be available in our next major release of Telegraf, and I believe it's 1.13, which should be out actually quite shortly, I think in the next few weeks. I'm not in product, so don't hold me to that, but maybe they'll get mad at me. Hopefully not. This takes the stuff that we pivoted, right? So adding the information into the field key and merges them into the same line. So now we've taken two lines of line protocol and made them one. So it basically finds every common series key and then puts all field keys into this, or fields in general, into the same line at the same timestamp. And here's an example of kind of what it looks like to be, before you've merged a whole bunch of fields into the same line. Here's an example of stock prices. I'm monitoring BP, Chevron, and ExxonMobil here. And in this case, I have 3 unique series indicated by the below. Those are actually just points in time. So those are at time 1. So basically at each time, 1, 2, 3, and so on, I have one single value, right? 3 series, each has one single value at each point in time. But price itself is very generic. I don't really want just price, right? If I really want to do some more advanced trading or algorithm or model training and all that stuff, I might want to use something like candlestick data. So at every point in time, I actually have multiple different metrics for the same series. So in this case, I'm monitoring ExxonMobil alone, and my measurement is stock prices again. And again, the ExxonMobil is the symbol, so I'm going to make that my tag, right? That's going to be something I group by. It's my metadata. But I have in this graph here, at every point in time, I have an open price, a high price, a low price, and a close price. So if you're not familiar with candlestick data, this is like a basic version of that. And it shows more information, right? And I'm doing it all in one single point of line protocol or a single line or record. So by writing it this way, I'm not only getting more information, but I'm also reducing payload and increasing write performance on disk. And then this is, I think this is my final slide. So this is kind of an example of it all put together. This is this from section here is if you notice everything before this first space, which is before the word usage, it's all the same. It's the same series key. So why write it? Why write all of that over and over the wire? Instead, I can merge all of those fields into what you see below, into one single line. It doesn't look like one single line because it wrapped, but it is one single line according to Influx. It's much less of a payload. You can absolutely gzip things, gzip these lines over the wire. So if you are just worried about the payload, there's a workaround there. But there are write performance implications with the gzipping. So it's best to just format at the edge just like this into this two result, and write your data that way. And that's hopefully in the next couple of weeks, Telegraf will be able to do all of that for you, and you won't even have to think about it. And that'll do it.
Excellent, excellent, excellent. Well, we are going to get started with the question and answer period. Want to remind the audience that there's plenty of time for questions. So if you have one, please go ahead and use your GoToWebinar control panel and submit your questions. And we'll go ahead and jump right on in here. Here's the first question for you, Sam. Can you talk a bit about what options there are for acting on metrics? What does the stack do to enable automated alerting and actioning on metrics coming in?
Awesome. Yeah. So there's actually quite a lot to be said here. I think I can think of 3 and then a kind of catch-all. So the first one is probably the most common when using Influx. Doing basic alerting, about 80 or 90% of our users use Grafana. I'm sure most people online here and people listening later are familiar with that. Grafana does support some basic, threshold alerting. So you can do that, and I think that's what most of our users probably do, at least at first. So Grafana alerting on top of Influx is a viable method. Influx has also created something called Capacitor, also open source, which is designed to interface with Influx, so it can either stream data out of Influx or batch it out and process it in some way using our domain-specific language and send off alerts to any number of outputs. It could be Slack, it could be PagerDuty, it could be VictorOps, OpsGenie, or any HTTP endpoint that you describe. We also have a new query engine called Flux, which also handles this kind of thing with tasks, works similarly to Capacitor. And then fourth, we're a platform, right? It's a fully open API. So we have people building applications fully on top of this. So they might use Capacitor or write their own clients to just take data and create alerts on their own, in whatever way they see fit.
All right then. Okay, let's see. Our next question. Is InfluxDB available in the AWS Marketplace or a pre-built container image on Docker Hub?
Both. So
All right.
InfluxDB open source and enterprise is available. They're both available on Docker Hub in different versions. And it is a open source and I believe enterprise are both offered in AWS Marketplace. Enterprise I have to confirm, but I do believe that's been out as of recently.
Okay. All right, awesome. Just a reminder to folks, if you have a question, go ahead and get it in and we'll get to it for sure. Our next question is, which programming languages have been used in the platform's development?
Great question. So that all of the core code of every piece of the tick stack, so that includes Telegraf, capacitor, which I mentioned, Influx, and then also our visualization chronograph, is all written in Go. And then of course our web application has TypeScript and React, things like that, but it's all Go written at its core.
Okay.
Golang.
Awesome. All right, guys, if you have a question, please go ahead and get it in. Next question here just came in. This is a good one. Are there any considerations with using InfluxDB with a different monitoring stack like Sensu?
Absolutely, yeah. Sensu's a close partner of ours. That we attend each other's conferences and everything. So we have tons of users and customers that use both. It's a good stack, I would say.
All right. Are there?
We have some pretty detailed documentation on doing that as well.
Okay, so there are certain considerations that folks need to keep in mind then. So.
Oh, there's not. I don't think there's necessarily certain considerations, at least different from any other kind of alerting endpoint. There's certainly no. I don't think you have to change your usage of Influx at all for that.
Okay. All right. Cool. Excellent. Well, that's all the questions that we have in right now. I'll give the audience another minute or two to see if we get any final questions in. And just a reminder that the webinar has been recorded or is being recorded. So if you miss any or all of the event, or if you just want to listen to it again, you'll have the opportunity to do so. We are going to be sending out an email that contains a link to access the webinar on demand. That should be coming over this afternoon. The webinar is also going to be living on the devops.com website, so you can always find it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. And it looks like we are not getting any more questions in, so I'm going to give everybody about 20 minutes back in their day. Sam, thanks so much for a great presentation. Lots of really good technical information in here. I love that stuff. So thanks again. I appreciate it.
Happy to be here. Thanks, Charlene.
Awesome.
Thank you, everyone.
Awesome. All right, great. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off now. Have a great day, everybody.